Have we discussed this one already?
Wala pa, ma'am.
Okay, so muna siya itong first nga kung ano. Let me check. Okay, so we will have rotational motion. So rotational motion is divided into two. We have the rotational kinematics and then rotational dynamics. Okay, so all right, so these are examples of rotational motion. So basically any motion which is rotating about a fixed axis that is considered rotational. Okay, so consider a rigid body. So example this one, described by this line OP. So naa siya arrow no, kini siya from here up to here. This is your rigid body. So a rigid body is anything, any object that is not a point. Okay? So it is rotating about a fixed axis. Now, haman ani iyang axis of rotation. So mura siyang clock that is rotating about this axis, the z-axis. So if this is the x-axis, this is the y-axis. Nag-rotate ni siya about the z-axis. So mura siya, you can imagine here a line that is the same as that of mura siya og gituhog ni siya nimo og barbecue stick class, and then kini siya gatuyok-tuyok ni siya about that line. Okay, so mo to siya iyang axis of rotation. We can call this the axis of rotation along the z-axis. Okay, now as the body rotates, it travels a certain arc length s. So for example, kung butangan ni siya nako og ink, so gikan diri no, gikan diri asya, initially gikan siya diri. So kung butangan ni siya nakog ink sa iyang tumoy, mag-trace na siya dira sa iyang path, okay? So from here up to here, we call it the arc length, which is denoted by the small letter s, okay? So the arc length can be mathematically defined as r times theta, okay? So we define r as the length from the origin towards the point P. So this is the distance gikan diri sa center towards the point P that we are considering. And then theta is the displacement, the angular displacement. So gikan siya diri, initially theta equals 0, and then na-displace siya after some time. So this is your theta. Okay, if you multiply r and theta, you will get the arc length. So unsa ganito ang arc length? Ang arc length kay kini siya no, the length nga na travel sa imo ang rigid body. Okay, now from here you can see that theta is just equal to the ratio of the arc length and r. So theta here is called the angular displacement. Okay, so it is the rotational analog. Theta is the rotational analog for displacement d sa katong kinematics na to nga equations. Okay. Now, theta, the angular displacement, is usually measured in radians. So, for example, if mahuman niya ang tibuok circle or kumubalik siya sa iyang original position, ang iyaang natuyok ato class is 360 degrees. Okay? The whole circle. Now, that is equivalent to 2 pi radians. So, it is important that we know these conversion factors. Okay, for example, if we will be given with degrees, we will be able to convert it to radians. Okay? So, ang 1 radian is equivalent to 57.3 degrees. And kini siya may kasagara ginagamit ng conversion factor. 180 degrees katong 1/2 sa imong circle. Okay. So for example, can you know? So this is 90 degrees. This is pi over 2. And then kini siya is another pi over 2. So ang iyang na the travel na is pi. So this is 180 degrees. Okay? So if you want to convert degrees to radians, then you can use this equation. So pi over 180 degrees multiplied by pila ka degrees. For example, 360 degrees, you want to convert it to radians. So 360 times pi over 180, you will get 2 pi. You will get, masaya mong makuha class, 2 pi radians. And then, for example, you want to convert radians to degrees, then you have to use this equation. So take note of kung asa dapat nimo ibutang ang degrees o ang radians para mag-cancel out, no? Okay. So please take note of this conversion equations. Now, we define the angular velocity as the ratio of the angular displacement over the time interval. So as you can see, as your rigid body moves about its fixed axis, mag-change ang value sa theta, no? So mag-change ang value sa theta per unit time. So if we account the ratio of the angular displacement with respect to the time interval, we will get the angular velocity. So nakay theta final minus theta initial divided by the time interval, T2 minus T1. Okay, so this is the rotational analog for velocity V. Okay, so the average angular velocity is just equal to the change in theta with respect to time. Now take note that if the average velocity is positive, it means that the value of your theta increases. So for example, positive ang value ni omega average kung mas dako ni siya, this is greater compared to this, no? Positive ang value sa imong omega average. However, if theta is decreasing, meaning mas gamay ni siya value compared to this, so theta 2 minus theta 1 is negative. Therefore, your omega average is negative. Okay? Now, the SI unit for angular velocity, kung ang unit sa velocity class is meters per second, the angular velocity, it has units of radians per second. And for the angular acceleration, it is the ratio of the change in velocity with respect to time. Okay, so kung mag-change as it moves, diri a class, kung dili constant ang velocity, then naay angular acceleration ang imo ang rigid body. Nag-accelerate siya. No? So, omega changes, if omega changes with respect to time, then naay acceleration ang imo ang rigid body. However, kung constant po ang imong omega as it moves tuyok-tuyok here, wala siya angular acceleration. Okay? So you have this one, omega 2 minus omega 1 divided by T2 minus T1. Or it is equal to the change in the angular velocity omega divided by the change in time. Now, the same with the angular velocity, ang imo ang acceleration class is positive kung ang imong omega kay ka-increase. Okay? So if omega is increasing, then the average acceleration is positive. However, if omega is decreasing, then negative ang imo ang average acceleration as seen in this equation. So kung mas dako ni siya si W2, nag-increase ang imo ang omega, positive ang value sa imong alpha. Pero kung mas gamay ni siya compared ani, so negative ni siya nga term diri so your angular acceleration is negative. Okay? So the units for the angular acceleration is radians per second squared. Comparing it to the linear acceleration A, ang unit ato kay meters per second squared. All right. Now, if the motion has a constant acceleration, then we can use these kinematics equations. So, let us compare this to the linear motion class, rectilinear motion, for example. So, as you can see, pareha ra sila form, except that kini si V, giilisan na to og omega, si X or pwede pod Y atong gamiton diri no? Kung along the Y-axis ang motion. So this has been replaced to the angular velocity for rotational motion. So ang imo ang A, so as you can see, giilisan ni siya og theta naught. Ang imong V, giilisag omega. And then, imo ang A, the linear acceleration has been replaced to alpha. So, this is for rotational motion. Okay? So, again, si theta mo ni siya ang rotational analog for displacement. Omega is the rotational analog for velocity. Alpha is for the acceleration. Okay? So, dali ni siya ma-memorize class because familiar na kay mo aning kinematics equations for linear motion. Pareha ra gyud siyang form sa rotational motion. Giilisan lang nato ang mga variables sa iya ang analogs. Okay. So, let us relate now linear and angular kinematics. So, here is another rigid body here. Okay. So, we have here another rigid body. So, wala siya fixed nga shape, no? It is, and then we want to know the velocity at this point. Okay. So, take note that when a rigid body rotates about a fixed axis, every part in the body moves in a circular path. Okay. So, kini nga point. Kung ato ni siyang i-trace, butangan na tog ink ang iyaang diri nga part, maka-form na siya og circle. Now, for example pod, kung diri ta magkuha og point nga i-consider, circular motion gihapon na iyaang path. Okay? So, every part in the body moves in a circular path. All right. Now, the length rotated by the body is equal to the arc length, which is equal to this equation, S equals R theta. Okay? And then, now if there is a change in the arc length at any given time, there is also change in the angular displacement. So, we can say that a change in S, the arc length with respect to some time, is equal to R multiplied by the change in the angular displacement with respect to time. Okay? So this one, si S divided by T, this is actually the tangential velocity or the tangential speed, V. So tangential siya, ing ani ang direction, it crosses the circular path only once. So, dili siya, kung mayon kag tangential class, dili siya pareha ani nga. Mo-cross siya kaduha sa imo ang circular path. once lang yun siya mo cross sa imong circular path. Okay? So, tangential speed is equal to this one. And then, kini siya diri, we know that this is equal to omega, right? This is the angular velocity omega. Angular speed omega. Okay, so we can rewrite this as V is equal to R omega. The tangential velocity of your particle is equal to R multiplied by omega. Again, R is the length from the center towards the point that we are considering. Okay, so this is the relationship relating the linear speed and the angular speed. V is equal to R omega. Now, as to the angular acceleration, so as the velocity changes, mag-change po ang angular velocity. Okay? So, the tangential velocity, tangential acceleration, this one, this is your tangential acceleration, it is equal to R alpha. Okay, so take note of this equation. A tangential is equal to R multiplied by alpha. So this is the relationship between the linear acceleration as well as the angular acceleration. Okay. Now, aside from the tangential acceleration, we know that for circular motion or rotational motion, natay ginatawag nga centripetal acceleration, which is always directed towards the center of the circular path. Okay, so take a look at this drawing, class. Muna siya ang inyong tangential velocity, always tangent to the circular path. And then, muna siya ang direction sa imong tangential acceleration. Pareha sila actually og direction sa imong tangential velocity. And then, aside from the tangential acceleration, naapod tayo radial acceleration or centripetal acceleration that is always directed towards the center of the circular path. Okay? So, recall, kung makadumdum pa mo, class, centripetal acceleration, A sub C, ang ato ang gigamit ani sa una. Dynamics nga part or yeah, I think it's dynamics nga part or kinematics ba to. The acceleration, the centripetal acceleration, this one, is equal to V squared over R. So it is dependent on the speed squared and the radius of the circular path. So you have this one, V squared over R. And then replacing R omega for velocity. So we know that V tangential, kuha na to ganina, no, sa previous slide. This one, V tangential is equal to R omega. So substituting R omega for V tangential, you have R omega squared divided by R. So you have here R squared omega squared divided by R. So cancel this and 1R here. So we are left with omega squared R. Okay, so the radial or the centripetal acceleration is just equal to omega squared times R. Okay, so it is always pointing towards the axis of rotation. So that the linear acceleration A, nasa duha ka components, si A tangential o si A radial. Okay, so take a look at this. We can get the linear acceleration, padulong dahil siya diri, and it is composed of the radial acceleration as well as the tangential acceleration. So we just have to substitute here R alpha squared, and then you have here omega squared R. Okay, now, so knowing all those things, mo to siya ang relationship sa imo ang linear motion o rotational motion. Okay, so they are somehow related. So again, class, as the body rotates or as the rigid body rotates, na siya duha ka types of motion. Ang isa kay linear, ang isa kay rotational. So kini siya nga chapter, we are accounting for the rotational motion. Okay, so suppose you have many objects or many rigid bodies that are moving at a certain axis of rotation. Okay, so nakay 1, 2, 3, 4, 5. So the kinetic energy of the particle, pwede na to ma-account sila individually, and it is equal to 1/2 mv squared. So depending on the particle. So for example, muna siya si particle 1, 2, 3, 4, 5. So nakay kinetic energy of particle 1, K1, is equal to 1/2 m1 v1 squared. Okay, now we replace v here. Ilisan ni nato si v diri ug r omega. Okay? So v is equal to r omega. So that ilisan ni siya nato diri og r omega. Now, this will now become of our equation for the kinetic energy. We have here 1/2 mi r sub I squared omega squared. Okay? So again, kini siya nga expression sa kinetic energy class is true for rotational motion. Okay, so if you want to account the total kinetic energy, you just have to add all the kinetic energies of the individual particles. So take note of this definition of the kinetic energy class for rotational motion. Okay, so again, i-add lang na to tagsa-tagsa ang kinetic energy nilang 5. For example, the total kinetic energy is equal to the summation of all the K's of the individual particles, or it is equal to 1/2 m1 r sub 1 squared omega squared plus 1/2 m2 r2 squared omega squared, and so on. Now, we can generalize this. So, pwede na to i-factor out ang 1/2 because it will be common to all tanan nga components sa imo ang kinetic energy class. And then also, omega is constant. So, pwede po siya na to ma-factor out. Okay? So, ato lang dayong i-add is kini si m1 r1 squared, m2 r2 squared, and so on. So, let's do that. Okay? So, you have the kinetic energy is equal to 1/2 factored out because common siya sa tanang equations. Bisag kapila-pila kabuok terms ato ang idungang diri na siya 1/2 tanan. Naapo na siya omega squared tanan. Okay? So, we can factor it out. And then, what is left inside the summation is m sub I r sub I squared. Because it is dependent. Mag-vary man ang mass. Okay, as you can see. And then, mag-vary po ang imo ang r with respect to the center. Kini siya lahi ni siya value sa r. This one, medyo taas. Kining mas dool, medyo gamay lang ang iyang value sa r. So on. Okay? So, we can call this as I. Okay? Ato ni siyang isulat as I para gwapa lang tawon atong equation. So, from this equation, 1/2 mv squared, it has now been translated. Ato siyang i-reconstruct in terms of r and omega. So, naabot na ta aning equation. Okay? And then, kini, para simpler, ang ato ang pagsulat sa kinetic energy, we will call this as I. Okay? I. So, unsa man ni si I class? You have K is equal to 1/2 I omega squared. This is the kinetic energy of rotating particles. So I is the moment of inertia of an object. Okay, take note of that. I is equal to the summation of MI/RI squared. So it is the moment of inertia of an object. So the greater the moment of inertia, the more difficult it is for the object to start a rotation or to be to be stopped from rotation. Okay, so for example, we have here a rotating kettle. So it is rotating about this axis. Its moment of inertia is equal to this one, summation of M sub I R sub I squared. Now we have two cylinders here. One is a hollow cylinder, and then the other one is a solid cylinder. Adit lang class. I was checking if naapaba mo. Ano ganita?
Katong mga spheres, ma'am, katong kettle.
Okay, so this one. So as you can see, different objects have different values of moment of inertia. So for a hollow cylinder, ang iyang value sa moment of inertia is equal to mass multiplied by r squared. So r here is the radius of your cylinder. So kininong gikan sa center padulong sa diri amo na siya iyang radius. So you have I is equal to m r squared. But for a solid cylinder, meaning to say, dili siya hollow, na siya kanang wala siya buho diri sa tunga. Solid gyud siya tanan, packed. You have I is equal to 1/2 mr squared. Okay, so this is the value of the moment of inertia for two cylinders, sorry. Two cylinders, one is hollow, the other one is solid. For spheres, so kini siya class, this is a hollow sphere, meaning to say, marag kanang bola sa ping-pong, for example, or basketball, kini siya kay solid nga sphere, like that of kanang bitang golf ball, for example. Solid siya. Okay, so lahi-lahi po value iya ang moment of inertia. So you have I equals 2/3 mr squared, while for the solid, it is 2/5 mr squared. And then kini kay pareha gid sila, rod. Okay, parehas sila length, L ilang length. But lahi-lahi lang sila og axis of rotate, lahi lang ang ilaang ga-rotate sa ilaa. This one is, it is rotating about its center. So ang iyang moment of inertia is 1/12 ml squared. L here is the length of the rod. And then kini, diri siya nagtuyok sa iyang isa ka edge. So lahi pod ang iyang value. I equals 1/3 ml squared. Okay? So to, the greater the moment of inertia, the more difficult it is to start an object to rotate. So lisod siya patuyokon kung mas dako siya moment of inertia, lisod po kung nagtuyok siya daan, lisod po siya paundangon. Okay? So here are other examples. Muni siya pareha ni siya ganina sa rod, nagtuyok-tuyok about this axis with length L. So na kay moment of inertia equal to 1/12 ml squared. And then kini siya nagtuyok-tuyok siya about sa iyang edge aning axis. So you have 1/3 ml squared. And then for a rectangular plate which has ang iyang axis is through the center. So, magtuyok-tuyok ni siya diri. Okay, so yeah, ang moment of inertia is equal to this one. 1 over 12 multiplied by the mass of the rectangular plate multiplied by a squared, iya ang width. Tapos plus b squared, which is the length. Okay, and then here is another rectangular plate which axis is along the edge. Nadiri yung axis. So, magtuyok-tuyok ni siya diri paana. Okay? So, ang iya, dili siya dependent sa B. It is equal to 1/3 MA squared. Okay? Walay labot si B or di siya dependent on B, the length of the rectangular plate. And then here is a hollow cylinder. Pero, unlike sa hollow cylinder kaganina nga ato ang consider, kini siya kay naa siya inner radius ug outer radius. So, lahi pud siya og value ani I equals mr squared man iya ano kung thin nga cylinder. Thin-walled nga cylinder murag kanang sa lata sa gatas. Okay, kini siya mura siya og tubo nga baga na siya inner radius, na pud siya outer radius. Okay? So it's I, the moment of inertia is equal to 1/2 times m multiplied by radius 1 squared, so the inner radius plus the outer radius squared. So muni siya tong sa solid nga cylinder, it is equal to 1/2 mr squared. Kini siya kay katong sa nipis nga walled, thin-walled, hollow cylinder. So it is equal to mr squared. And then this is for the sphere, solid sphere, 2/5 mr squared. And then for the hollow sphere, kini, it is equal to 2/3 mr squared. All right. So let's have problem number 1. Problem number 1. An airplane propeller is rotating at 1900 revolutions per minute. Compute the propeller's angular velocity in radians per second, and how long in seconds does it take for the propeller to turn through 35 degrees? Okay? So, what are given? So, we are given with the angular speed class. This is the angular speed. Revolutions iyang gigamit per minute. So, 1,900 revolutions per minute. Okay. Now, take note of this. 1 revolution, ang isa katuyukan, that is equivalent to 360 degrees or 2 pi radians. Okay, so kada minuto daw, mutuyok ang propeller sa airplane og 1,900 revolutions. Okay, so let us compute the propeller's angular velocity. So this is the angular velocity, omega in revolutions per minute. Ato siyang i-convert into radians per second. Okay, so convert 1900 revolutions per minute to radians per second. Okay, so mura ni atong nahibalaan. 1 revolution equals 2 pi radian. And then another thing that we know of is that 1 minute is equal to 60 seconds. Okay, so let us now convert 1900 revolutions per minute multiplied by what conversion factor should be used? So you have 1 rev in the numerator is equal to 2 pi radians. Okay, so by doing this, we can cancel out the revolutions. And then multiplied by this conversion factor. So to eliminate minute, we have to put it in the numerator and then 60 seconds in the denominator. Okay, so let us calculate that one. We have 1900 times 2 pi divided by 60. Pila na siya, class? So I don't have my calculator with me. I'm using a cellular phone. So 63 pi, sakto ba ni? Or pwede na to i-eliminate ang pi. I-convert din siya to numbers. So 1,900. Nanay nakakuha, class? 1,900.
63.33, ma'am.
63.33. Walay pi?
Naipay, ma'am.
Okay. Divided by... Okay. So, ang uban kay ingani ang makuha sa kalkino 63.33 pi radians per second. And then apoy uban ang ilang makuha kay katong multiply gyud ni siya si pi. 198, no? 198.96 radians per second. Okay? So, this is how we convert angular velocities from revolution per minute to radians per second. So you just have to recall these conversion factors. All right. Now, how long in seconds does it take for the propeller to turn through 35 degrees? How long in seconds? Okay, so for this, we will be using this equation, katong kinematics equations. Itong kinematics equation plus na kay omega is equal to omega naught plus alpha, times time. Okay, so I guess we cannot use this because we do not have alpha. So atong gamiton? So atong gamiton nga equation to find the time. So can you recall the kinematics equation nga na time pero walay acceleration? So this has time, time, kini walay time. So asaan ni ang walay? This one. Sakto ba? Equation number 2. Okay, so can we use equation number 2? Equation number 2 for this. So what was the equation? Okay, so di na siya ma-erase. So the equation that we can use is, pwede na po kiniklas itong gamito, no? Omega is equal to change in theta with respect to time. So the definition itself of omega, we can use it. Okay, so we have, atong pangitaon is time. So delta t equals delta theta divided by omega. Okay. Now, gitagaan na tadaan og delta theta. So, wala ta gitagaig theta final o theta initial. Ang gihatag sa ato diretso is katong change in the theta. Now, we have to convert this to radians. Okay, so convert first. So using this equation, kini siya nga equation, we can get the time. But first, we need to convert 35 degrees. Okay? So convert first 35 degrees to rad. So 35 degrees multiplied by 180 degrees per pi rad. Okay? So this is equal to 35 times pi divided by 180. Can you solve that one? 35 times shift pi divided by 180 degrees. So, pila siya ka-radians, class? Or pwede na po 35 over 180 times pi. .6109. Okay. Or you can just use atong na pi.
0.61, ma'am.
0.61, no? Okay.
Yes, ma'am.
Okay, 0.61. $35 divided by 180. Okay. So it's 0.61 or 7 over 36 pi. Nabay nakakuhag 7 over 36 pi dira. So correct yapon na siya, no? 7 over 36 pi. Or 0.6109 radians. Okay. Now that we have what's this? The radian form of 35 degrees, then we can then calculate delta T. Okay? So delta T equals 0.6109 divided by so ganitong omega class. Omega nga itong nakuha, this one. 190.96. 198.96. Di ba klaro? Okay, so it's 198.96. Okay, so pila man ni siya?
0.003, ma'am.
0.003. 0.003 seconds. So, dali ra kaayo kay makatuyok na siya 35 degrees in just a very small fraction of time because kusog man kay siya og angular velocity. Sayunan kag 1,900 revolutions kada minuto. So, gamay lang nga segundo, makatuyok na siya 35 degrees. Okay? So, any question for this problem? Okay, so let's proceed to the second problem. Napatay time, no? Okay, so a bicycle wheel has an initial angular velocity of 1.5 radians per second. If its angular acceleration is constant and equal to 0.3 rad per second squared, new slide. Okay. What is its angular velocity at after t equals 2.5 seconds? And then through what angle has the wheel turned between t equals 0 and t equals 2.5 seconds? All right. So for this, I guess we will need to use one of the kinematics equations problem. So let us identify first the given. This is the initial angular velocity. Okay, given. Omega naught, 1.5 radians per second. And then the angular acceleration alpha equals 0.3 radians per second squared. And then what is asked is the angular velocity at time t equals 2.5 seconds. Okay? So ang gipangita class asked is omega final. Okay? So what is omega final? And then for letter B, through what angle has the wheel turned between t equals 0 and t equals 2.5 seconds? So we are asked to find delta theta. So what is delta theta? Okay, now let us start first by answering letter A. So this is our solution. Sa nga equation atong gamiton. So we can use
Equation 1, ma'am.
Okay, very good. So we have omega equals omega naught plus alpha times time. So from this equation, we can get omega directly. We are given with the initial velocity, angular velocity, which is 1.5 radians per second, plus the angular speed, angular acceleration is also given. It is 0.3 radians per second squared, multiplied by the time, which is also given, 2.5 seconds. Okay? So, pila man niya siya?
2.25, ma'am.
2.25? 2.25, no?
Yes, ma'am.
Yes, ma'am.
2.25 radians per second. So, ni-increase ba or ni-decrease ang iyang velocity? Ni-increase ang iyang velocity. Okay? From 1.5 radians per second, himo siyang 2.25 radians per second. It is expected nga mo increase gyud siya because positive man ang ato ang acceleration. So as you can see, acceleration, the average acceleration is positive. So it is expected that the wheel has an increasing angular velocity. Okay, so how about this one? Through what angle has the wheel turned between t equals 0 and t equals 2.5 seconds? What should we do? So we have theta. Theta equals theta naught plus, so to 1/2. Is that theta naught, omega naught t plus 1/2 alpha t squared. Sakto ba niya to ang equation ng gamiton class or gabuot-buot na tani? Baliko sa nako class ha kay para sure good ba? Okay. Yeah, this equation. We can use this equation to find, sige ito itong pangitaon, theta, delta theta. So, kinino, delta theta. Okay, so correct to itong equation. We can also use this equation since kabalo naman ta sa omega, kabalo po ta sa omega naught. But let's try this one. Okay, so this is basically the third equation. omega naught t plus 1/2 at squared. Katong dito kaganina kay na lang ni sa left hand side of the equation. So theta minus theta naught. Okay? Theta minus theta naught equals omega t plus 1/2 alpha t squared. Okay, it is just the same. Now, yes, we are asked to find delta theta. So, initial for this. So, ng delta theta, theta initial minus theta final. So, nakay theta minus theta naught. Kung ibalhin siya sa left-hand side of the equation, mahimo siyang negative equals omega naught t plus 1/2 alpha t squared. Okay, so we will use this equation, class. This is your delta theta. So, ito na siyang i-evaluate. Okay? So, you now have theta minus theta naught equals omega naught t plus 1/2 alpha t squared. Ako lang yun siyang gi-copy, class. So, this is your delta theta. Omega naught is 1.5 radians per second multiplied by the time. So, ang time, class, gikan siya from 0 to 2.5 seconds. So, imo lang na siyang i-minus time interval 2.5 minus 0. So, you will have 2.5. 2.5 seconds plus 1/2 times alpha, which is 0.3 rads per second squared multiplied by 2.5 seconds squared. So, pila man ni siya?
4.69, ma'am.
4.69.
Yes, ma'am.
Naka-square naman ka na si 2.5.
Yes, ma'am.
Okay, so it's 4.69. Very good. 4.69, the unit is radians. Okay, radians ang unit ani class because this is rad per second. Kini siya second, so makancel out ang second no na nakay radians diri na bilin. Kini siya kay radians per second squared. Kini po siya kay second squared ang unit, so makancel out ning second squared diri ana kay radians po diri nga term. Okay, so you will get 4.69 radians. Now, we can also use the other equation katong theta, another solution. I do not know if, of course, we will expect the same answer, but let's try this one. Theta minus theta naught, equation number 3 ni siya, ay number 2, katong ganina equation number 3 to atong gigamit. 1/2 omega plus omega naught times t. Can you solve this one? So you have 1/2 times omega is 2.25 radians per second plus ang omega naught kay 1.5 radians per second multiplied by 2.5 second. Lah, magdili lagi. 2.25 plus 1.5 times 2.5 divided by 2. Parehara des lakas. So it's 4.685. The same answer, 4.69 radians. Okay? So you can use either of the two equations to solve for delta theta. Okay, how about this one? A flywheel requires 4 seconds to rotate through 162. Wala na patay time. We have 4 minutes left. A flywheel requires 4 seconds to rotate through 162 radians. Its angular velocity at the end of this time is 108 radians per second. Find the angular velocity at the beginning of the 4-second interval and the constant angular acceleration. Okay, so let's try to solve this one before we dismiss. So given 162 radians kada 4 seconds. Okay? So kada upat daw ka segundo nga tuyok-tuyok sa flywheel, ang iyaang matuyok ana tanan kay 162 radians. Okay? So what is its angular velocity at the end of this time is 108 radians per second. So after 4 seconds, the final velocity omega is 108 radians per second. Find omega naught. Okay. So muna siya iya ang theta class. And kini siya muni ang time t. Okay, so let's solve for omega naught. Itong mag-report sa inyong next class, pwede na mo mag-dismiss og early. Hindi na mo human ani nga kanang sa pangalan ni problem. Anyway, i-post man ni siya nako so you can review this. Okay? So, unsa nga equation atong gamiton class for this? Ang gipangita kay si omega naught. Ang given kay kani. So, nga equation atong gamiton kaya. So, wala kay alpha, no? Wala kay alpha. So, unsa nga equation sa atong kinematics equations ang walay alpha? This one. Wala siya alpha. Okay? Equation number 2. The one we have used kaganina po sa previous nga problem. So use equation number 2. You have theta minus theta naught equals also to 1/2 of omega plus omega naught times time. So kini siya, kining gihatag class, this is the delta theta minus theta naught. So itong ipangitaon kay time. So manipulating para makuha nato ang time, so you have time is equal to cross multiply ni siya nato diri. So you have 2 multiplied by theta minus theta naught divided by kani siya sa denominator omega plus omega naught. Okay? So this is the equation that we will use. So these are just numbers, class numbers sa tanan. So you have t equals 2 multiplied by omega plus omega naught. Pila ng omega? Kasi makadum omega. Ay, dili t ang ipangita. Sorry class. Ang omega naught din ang ipangita. Okay? Let me just erase this one. Sorry. So, ang gipangita kay si omega naught. Okay, so to find omega naught, ato yun ni siya ang bungkagon. So, theta minus theta naught equals 1/2 omega t plus 1/2 omega naught t. So, gi-distribute na ko ni si 1/2 o si t class ha. Muna siya ang nahitabo. Gi-distribute lang na ko si 1/2. Multiply na ko siya kay omega. Multiply po siya kay omega naught. Kini po siya, gi-multiply po na ko sa omega o sa omega naught. So, you have 1/2 omega t plus 1/2 omega naught t. So, kailangan siya na to ing-anion para ma-isolate na to si omega naught. Alright? So, you have theta minus theta naught balhin siya nako sa left-hand side of the equation. It will become negative 1/2 omega t. And then, para ma-isolate, okay, sulat lang sana ko ha. Equals 1/2 omega naught times time. Sorry. It's already time. So, katong mag-report class, you can leave first. Alright, so you have, so ito equation, theta minus theta naught minus 1/2 omega times t equals 1/2 omega naught times t. So, kailangan na ito i-isolate sa omega naught. So, dapat siya na lang mahabilin dira, no? Omega naught is equal to, kini ibalhin na ito, cross multiply. So, you have 2 multiplied by theta minus theta naught minus 1/2 omega t. So, divided by all over kining t diri. So, these are just number. Listen na siya na itong number class. Para makuha na to si omega naught. So, you have omega naught equals 2 times your theta minus theta naught is just equal to 162 rad minus 1/2. Your omega is 108 radians per second. Multiplied by the time. So, pila ganito ang time? 4 seconds. Divided by 4 seconds. Okay? So, you can now solve that one. Kindly solve that one. (108 times 2, 216. 162. Negative no ang answer? Minus 216. 54 times 2 divided by 4. Ito ba niya ako answer class? Negative 67. Omega naught is equal to negative 67.5. Radians per second. Is this correct? Can you please verify lang class kay akong kalkyo kay cellphone. Initially, na siya negative na omega and then nagka-increase. Now, napay last, kuwaon daw na to yung acceleration. So, to find the acceleration, we can use itong omega is equal to omega naught plus alpha times time. So, you have omega minus omega naught divided by time equals alpha. Okay, so you have alpha is equal to 108 minus negative 67.5 divided by 4 seconds. So, nakay-negative times negative, dira mo positive siya class. So, this is 175.5 divided by 4. Okay, so this is the acceleration. 175.5 divided by 4. So, it is equal to 43.875 radians per second squared. Okay, so we cannot afford to answer your questions kay time na kas 4:06. You have a next class. So, see you next meeting. We will continue with rotational dynamics. Okay, so we will have rotational dynamics. Goodbye, class.